Hi, today we're going to be looking at trigonometric functions of secant and cosecant and the like. These are a little bit trickier than yesterday, so we hold on for the ride here. Now, the identities we're going to use today are the co-functions for the Pythagorean identity. Now, how we get them? Very simple. We all know that sine squared plus cosine squared equals 1. Let me rewrite that. That's the sine squared of x plus the cosine squared of x equals 1. Well, if I divide everything by the cosine squared of x, that's going to give me the tangent squared of x plus 1 equal to the secant squared of x. How I get the other one, I divide everything by sine squared. Now, these are a little bit trickier, so we're going to try. We got to play around a little bit. A lot of times people think, if you just mess around with these, you're going to do something that probably will get you to your answer. So if I'm trying to integrate something like tangent to the fifth of x, secant of x, I start thinking, first I want to use substitution. So I first let du be, let's do secant of x. Is the du be secant of x? It's derivative of secant tangent. It's not going to quite cancel with all of that. So sometimes people think, okay, let it be tangent of x. Where's derivative of secant squared of x? Still not going to cancel. So for a problem like this, I'm going to manipulate a little bit. Remember, we just said that the derivative of secant of x is the secant of x times the tangent of x. Well, I do have that here. I have the secant, and I have 5 tangents. So what I'm going to do is I'm going to borrow one of these tangents. I'm just going to borrow that. And that's going to become the tangent to the fourth of x. Here's the one I'm going to borrow, the tangent of x, and I'm left with the secant of x dx. So I do have my derivative. Now the only other problem is the derivative of secant is secant tangent. So I am going to convert this one, kind of like what we did the other day with the sines and cosines. I'm going to convert this one. I can write tangent to the fourth of x as secant squared of x minus 1 squared. This is going to be secant squared of x minus 1 squared. And this is going to leave me with the tangent of x times the secant of x dx. Now, where did I get the square from? Remember, this is just the tangent squared of x squared. And I can manipulate this, and I can rearrange it to get me my tangent squared of x. Now I have my secant right here and its derivative over here. So now I can use u substitution. Let u equal the secant of x. Du is just the tangent of x, the secant of x, dx. So we get dx equals du over tan x, secant of x. Now it's really secant tangent, but it doesn't matter how you multiply them. That's that commutative property for us. And when I rewrite this, we get u squared minus 1 times tan x secant x du over tan x secant x. And those cancel. And forgot my square there. And what we're left with is the antiderivative u squared minus 1 squared du. When I distribute, this becomes u to the fourth minus 2u squared plus 1 du. And when you integrate, u to the fifth over 5 minus 2/3 u cubed plus u plus c1. And I plug in my secant. I get the secant to the fifth of x over 5 minus 2/3 secant to the cube of x over, sorry, I already had it over 3, just like that, plus the secant of x plus c1. And there's our final answer. I already had the 3 out there. Didn't need to divide it by anything. And there's our answer here. Very easy to do these. All right. So let's take a look at another one. Kind of the same technique. Now I'm going to do this one 2 ways. I'm going to do the same technique here. I know that the derivative of the secant of x is secant x tangent of x. I do have that. I have my tangent. And again, I'm just going to borrow one of these secants. So I'm going to write this as the secant cubed of 3x times the secant of 3x times the tangent of 3x dx. And this one's even much easier because there's my du. There's my u. So using u substitution, let u equal the secant cubed of 3x. Be very careful, the derivative. Du, not secant cubed, just secant of 3x. The derivative becomes 3 times the secant of 3x times the tangent of 3x dx. So dx equals du over 3 secant 3x tangent of 3x. Now kind of quickly, we know these are going to cancel. The 3 doesn't though, so we're left with that, so be very careful. And this is going to become just 1/3. We replace secant cubed with u, so it becomes u cubed du. And be very careful, those all stay the same here. So when we integrate, we get 1/3 u to the 4th over 4 plus c1. And if I integrate this, we get 1/12. Plug your u back in. Secant to the 4th of x of 3x plus c1. Now, if you go to part 2, we're going to take a look at this one right over here and do a couple more problems with us. Okay? So see you then.